We're now going to consider our final example together of a distance, rate, time problem. And the problem states, an earthquake emits both primary and secondary waves from its epicenter simultaneously. The primary waves travel 8 kilometers per second, and the secondary waves travel 5 kilometers per second. The primary waves arrive at a seismic monitoring station 2 minutes before the secondary waves. How far is the station from the epicenter? Now, before we organize the information into a chart, as we did with the previous distance, rate, time problem, there's something very important to notice before we proceed to that step. You'll hopefully observe that the rates for both the primary waves and secondary waves are given to us in kilometers per second. And a little further down, we're told that the primary waves arrive at a seismic monitoring station 2 minutes before the secondary waves. Now, what will be important before we write the equation is to be sure that we're expressing everything in terms of the same units. So what we'll need to do shortly will be to convert the 2 minutes to second to be compatible with the way the rates are expressed. So let's next proceed to setting up and organizing the information into a chart. So we're now ready to organize the information into a chart, and I've set it up as we've done in the previous example, where we have the two conditions for the two rows being primary waves and secondary waves, and across the top we've got distance, rate, and time. Now we're given in the problem a relationship between the times that the waves reach the monitoring station, and so I'm simply arbitrarily let x be the time for the secondary waves to reach the monitoring station. And we're told in the problem that the primary waves arrive 2 minutes before that, so the time for the primary waves will be 2 minutes less than that. But remember, we want the units to be all expressed in terms of seconds, and we know that 2 minutes is equal to 120 seconds. So we can then say that the expression for the time for the primary waves to reach the monitoring station will be then x minus 120. Now, let's go back and fill what we can into the chart. We are told that the rate for the primary waves is 8 kilometers per second, so we can put an 8 in here. And the rate for the secondary waves is 5 kilometers per second. And we just determined that we're going to let x be the time for the secondary waves to reach the monitoring station, and x minus 120 will be the time it takes for the primary waves to reach the monitoring station. And so we can easily fill in the distance column because we know that distance is equal to rate times time. So then we have 8 times the quantity x minus 120, and for the secondary waves the distance then will be equal to 5x. And we know that the distance between the epicenter and the monitoring station is the same for both waves, so our equation will be simply to equate the two expressions for distance equal to each other. So we'll take care of that next. So equating the two expressions for the distances equal to each other, we have 8 times the quantity x minus 120 is equal to 5x. And if we distribute on the left-hand side, we'll have 8x then minus 960. And on the right-hand side, we'll have 5x. And we'll take care of two steps at once here. What we'll do is subtract 5x from each side and then add 960 to each side. So that will produce then 3x is equal to 960, and if we divide each side by 3, we end up with x being equal to 320. Now you want to keep in mind that x represents the time it takes for the secondary waves to reach the monitoring station, which would be 320 seconds, because our units were in terms of seconds. But this is not the answer to the question posed in the problem. It asks us how far the station is from the epicenter, which is a distance. So all we need to do to find that would be to substitute 320 back into either expression for distance that we have in the equation above. And probably easiest to put it into the expression 5x. So we have then 5 times 320 will produce then 1600, and this will be 1600 kilometers. And as we've suggested before, it's always a good idea to end up with a sentence. So let's do that next. And so we end up by writing then the distance from the epicenter to the monitoring station is 1600 kilometers. And we're done.